Okay, have twot.
The twot has been...
The twot has been twitted. I don't know.
The twot has left the nest.
Hey, anyone who's in chat, how's it going?
A very merry morning, everyone.
We're on day 11 now. We're nearing the halfway point, and we're still getting the puzzles knocked out.
We certainly are.
In a decent amount of time, I think.
Yeah, what was it yesterday? Half an hour? Something like that?
Yeah,
maybe
something
40
like that.
minutes? This is the furthest I've ever come with Advent of Code.
I think last year I made it to 20, day 20 maybe, which was the furthest I've made it before. For me, it gets to a point where like I hit a puzzle which takes 3 hours, and then I'm like, you know what? No, I'm done.
For me, that was day 2 though. Still finished it.
Today I slept really badly and woke up late, so I just having my coffee this morning.
I feel like
sorry, go ahead.
I want to say I feel like every day pre-stream we're always like, yeah, how's it going? It's going. I just like, like both of us.
But this coffee is really, really good. It's, I get a subscription every 2 weeks. I get 2 bags of coffee delivered, single origin, light roast from different places. This one is from China, and it's really, really good. Really like floral and light fruits and stuff. It's really nice.
Oh, hold on. We have bird action going on in the background.
Bird action.
Yeah. I wasn't sure what was going on, but the little chirps means there's a bird.
Oh, I love those little chirps that the cats make when they see a bird. Like they smack their little lips. So cute.
Yes.
Marshmallow doesn't do it. Milkshake does it a tiny bit. Lexical cat like goes full on smacking lips, chirping. She's the only cat we actually have. Like people think we have 3 cats. We actually have 1 cat and a dog and a goblin.
Yes. Marshmallow, the space puppy, cat, dog, horse.
It's pretty much past now. Shall we have a look at the puzzle, or what?
Yes.
What do we think the picture is? I never worked out, like, is it always a picture of something, or is it just like a picture which is supposed to represent the journey we've gone on? I never quite know.
Oh, I was like, what picture?
Yeah.
But you're talking about this one?
The home screen.
I feel like it turns into like an actual like picture of something, right? At some point it was like a Christmas tree. I think like 2019 or something.
Alright, let's have a look at 11. Day 11, Dumbo Octopus. Enter a large cavern full of rare bioluminescent Dumbo octopuses. What do Dumbo octopuses look like? Oh, it's a YouTube video. Hi, Marshmallow. Oh my goodness, they're so cute.
Okay, this is fantastic.
This puzzle was worth it just for discovering about Dumbo octopuses.
Oh, do you see how they curl up into a ball?
Yeah, so cute. Alright, they seem to not like the Christmas lights on their submarine, so you shut them off. There are 100 cute baby little fluffy octopuses arranged neatly in a 10 by 10 grid. Each one slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Each octopus has an energy level, and our submarine can remotely measure the energy level of each octopus. We have a grid. Energy level is a value between 0 and 9. This one has 5, so on. can model energy levels of flashes of light in steps. During a single step, the following occurs. Each energy level increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including diagonally adjacent ones. If this causes an octopus to have an energy level greater than 9, it also flashes. This continues as long as octopuses keep having their energy level increased, and an octopus can only flash at most once per step. Finally, any octopus that flashed during the step has its energy set to 1. Okay. That makes sense. Runs through a fairly long example, but it seems fairly straightforward. So we count how many flashes there are after 100 steps. So this seems very, very similar to day 9, which was the one with, this one.
The other grid.
Yes. The caves and the lava flows, the smoke. Yeah. Okay. I'm all good. You all good?
I'm gonna try. I didn't finish day 9. Let's see if I can finish this one.
All right. See you
All right.
later.
Good luck.
Okay, Yosh is gone. So I'm just gonna, for now, copy day 9, since this is gonna be very similar. Let's not have map location like that. Let's map location with a short. And we'll use a couple of what are called tombstone values. So we want to put a halo around the input so that we don't have to check boundaries, and we'll give that a tombstone value of -2. And then we'll use -1 for octopuses which have already flashed this round. Okay, so that should get the what's it called? The input. Okay, and then we're essentially doing this flood fill algorithm again, but instead of doing it recursively, let's do it with a queue. So let's see, we will get our map, and then for line and map for octopus in line, we're gonna increment octopus. We'll keep a queue, stood queue of shorts, which is to flash. We will hash include queue, then plus octopus, and if octopus is greater than or equal to 9, then we're going to flash dot push octopus. Okay, so this will calculate all the octopuses we need to flash, and then we're going to do while to flash is not empty. We're going to right, what do we need to do? We're going to count the flashes, so flashes equals 0. So while we're not empty, we're going to make sure that what we're currently looking at is greater than or equal to 9. So that's the API for this. Similar to std stack. Push back and pop front. Okay, yeah, push, pop, front accesses the first element. if flashes.front is greater than or equal to 9, then plus plus flashes, and set our octopus to be 0. Sorry, -1. We'll make these pointers so that we just get pointers into the map. Yep. Okay, and then we will do toFlash.front equals -1, and do toFlash.pop. Okay. Then we're going to process all of the adjacent ones for auto I in std views, iota from -1 to 1, and from -1 to 1 again. We need, this shouldn't be storing a pointer, this should be storing coordinates because we need the coordinates. So we can do TL enumerate. Thanks to the follow 11 Sodenu. So we can pipe this to enumerate, we can pipe this to enumerate, which will give us line and I. Yes, that's one of my cat's marshmallow. This will give us J. Okay, so here we're gonna store just a pair of std size t, and we're gonna push ij. Okay, so if let's get x and y from this, destructure it. If map x, y, and here as well, map x, y. Okay, and then we're gonna do map x plus I, y plus j, and we're going to add this to the queue. I guess we should, let's increment it first, and then this is going to increment our boundaries and our already flashed octopuses as well. So let's just do a check. If this is greater than or equal to 0, then increment it, and then if it's also greater than or equal to 9, then add it to the flashes, to flash dot push I j, and then we don't need this check.
Hey, Sai.
Hey, what's up?
Hey, quick question.
Mm-hmm.
For this challenge, are you like also going to do just like day 9? Are you adding like a row, or what do you call it, like a wall around the grid?
Halo, yes.
Yes. Okay. How does that work? Because I didn't try it last time, and it seemed like that was a really quick way of doing it. So I'm kind of curious.
For this one, so in the previous one, I used a value of 9 to essentially surround the entire thing with walls. This time I'm
Right.
using a flag value, -2. Well, I'm using two flag values. I'm using one flag of -2, which means wall, and one flag of -1, which means this octopus has already flashed this turn.
Uh, I see. Oh, that's cool. I see. I see. Okay. Amazing. Yes, I shall. I shall do something similar. Thanks.
Cool.
Appreciate it.
No
Good luck.
problem. Okay, so where were we? We now need to go through all the octopuses which have already flashed and set them to 0 instead of -1. Don't need to enumerate. We could track these as we go along, but it's a 10 by 10 grid. This is not gonna take a whole lot of time. If octopus equals -1, then octopus equals 0. Okay, so this should be a single step of our algorithm. So now we just do for auto step in views iota 0 to 99, because we need to do 100 steps. Do all of this and put flashes out here. And then finally, did cout flashes. Let's give this a shot with the test input. Okay. Whoops, I ran day 10, not day 11. Thanks to the follow, Mr. Anderson OX. What's this up to? Yeah, don't do that. Configure. This is running slowly today. Don't know what's going on. I have too many programs running. Right, while it's doing that, let's double check our algorithm. So we go 100 times. We have a queue of things to flash. We increment all of them. If they're greater than or equal to 9, then we push them into our queue. We need tail enumerate. Let's build this. Then we keep. Oh, I didn't get rid of my part 2 from here. And thanks to follow W meter can. Okay, TL views enumerate. This is a mistake I've made almost literally every day, I think, forgetting to put views on the namespaces of things. Location undefined identifier. Yeah, this should be short. This should be short. Initializing cannot initialize convert from a std pair of unsigned long int to vector. Where's this line? 34. going on here? Am I using enumerate wrong? Let's make this a forwarding reference. Yeah, that worked. Oh, because the I cannot bind to an R value. Okay. Well, that didn't print anything out. That's not promising. Oh, because I didn't run part 1. I ran part 2, which doesn't do anything. Okay, so what are we expecting as our output here? We are expecting big number, but this hit debug assertion. Okay, well, Y is not something reasonable there, so what's into Flash? Yeah, those are all completely wrong. Let's try this again. I am coding advent of code. This is like a adjacency problems, kind of like game of life-y style thing. Right, what's I and J? I and J look reasonable there. So, to Flash, that also looks reasonable. That's what I would expect. Stick breakpoint here. To Flash. Yep, that looks reasonable. Oh. Here I should not be pushing I and J, I should be pushing X plus I and Y plus J. That's the problem. And what do we get? Another debug assertion failed. Is this an out of bounds error? Yes, this is an out of bounds error because I looping over every because I added the halo around the input, but I'm not taking that into account when I iterate. So let's just get rid of all this stuff I want to do for I in iota 1 up until map.size -1, so that I'm iterating within the bounds of the halo. And do the same. Oh, we already know that this is just a 10 by 10 matrix, so I can just do 1 to 10. J plus plus map I J, and this should be map I J. Okay, and this one should be fine because the outer bounds are always going to be -2, so I'm never going to change anything there. 2047, that is not the correct answer. Let's have a look. So let's do yeah, let's just take a breakpoint here and see what our status is after each step. Okay, so this should be after step 1. Our map. Yep, that's our line of -2's. That's fine. Okay, so what do we expect? After step 1, we expect a single... Oh, it's only... Okay, I misunderstood the instructions slightly. So we... With a level greater than 9, I had greater than or equal. Off by 1 errors. Love to see them. Let's try that again. $1,532. That's still not right. Jeez. We're making some silly mistakes today. So, our map after round 1. 659,425. 659,425. 4334. 4333. 4333. I've got another off by 1 error. This needs to be 11. Should have stuck with my size -1. Just a day of off by 1 errors. Let's just let this run to completion. 1619, was that correct? No. Oh my god. What is going on today? Okay, 4334. That's correct. 385,696. Where are we? Three, 85696. Okay, that's all fine. Have I gotten off by 1 in my number of steps? Does this need to be 100? $1626. That's still wrong. Okay. Alright, I must have a mistake somewhere then. Let's... Is iota inclusive or exclusive? I can't remember. Stood ranges iota. Exclusive. Okay. So that should be correct. Oh, that means these are wrong. Doesn't... I can't remember. Let's give it a shot, see what happens. 66545. Yeah, that's completely wrong. Alright, what's going on here? Anyone seeing what I'm doing wrong? Let's put breakpoint here. So what's the first point at which something needs to flash? step after step 2. Okay. So here, our map looks like 7, 6. Okay, so this is before we've done the flashes for this step. So to flash, there are 13 ones we need to flash. Let's see how many flashes we get at the end of this loop. Flashes. Put it on the wrong place. Okay, flashes. Oh, yeah. Geez, though. $2,667. Okay, something's going terribly wrong here. Anyone see my problem? Alright, so we first flash 1, 3. We set that to -1 here. We then loop so if it's greater than or equal to 0, which it's not because we just checked a boundary element, that'll be another boundary element. This one should also be a boundary element. Now this one should not be a boundary element. Okay, so we plus. This should increment our 6 here. Yep. Oh, we increment ourselves. And not I equals 0 and j equals 0. Try this again. Let's run to completion, see what we get. 6, 6, 4, 5 again. That's wrong. Okay, this one's not going so well. Okay, so here we should increment that 6. Yep. Then there's I and j. I and j should be 0, so we should skip this. Now we should increment the one to our right, which is this 5. Yep. Then we should increment this 9. Yep. And we should push that to the queue. Then we should increment that 6, then that 7. Okay. Okay, that looked right to me. So now to flash should be yeah, there's that 2-2 is the one which we just pushed. Okay. So how many flashes do we have after our first iteration? 2, 6, 6, 7. That's so wrong. Something about this loop is very wrong. Alright, so if the position we're looking at is greater than or equal to 0, so it hasn't already flashed and it's not a wall, and we're not looking at ourselves, then we increment our position, and if it's greater than 9, then we push the new position to the queue. Seems reasonable to me. Let's have a look at toFlash on every iteration. Okay. So lots of things are getting added. Feels like too many things are being added to this queue. I mean, it's okay if they're added because we if they're set to -1, then we'll just ignore them. Like, here's a 9-2 and there's a 9-2. So when we get to this 9-2, we should we need to do a check here. Yeah. If map x, y, because we might have added something to the queue when it hadn't already been processed, but then by the time we get to processing it, then we need to check that we're not already done. So we need to say if the map is -1, then continue. Let's try that. What's going on here? Why is this not terminating? Oh, because we need to pop it first. This code is getting uglier and uglier. "1656", that's right. Jeez, finally. Alright, let's get our input. Play it. 1562. That's the right answer. Jeez. Okay, Josh, we're done with part 1.
Hey, we're still working on it. It's a work in progress.
Cool. Do you want me to
Do you want
read
to
out
read
part 2?
Yeah, let's do that.
Alright, it says, seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is step 195. If you can calculate the exact moments when the octopuses will flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Alright.
Oh, that's cool. Isn't that just count the number of flashes like in a single step? Know how many octopi there are like in a total grid? Move from there?
Yeah, something like that.
Okay, cool. Well, see you in like 2 minutes.
Yep.
All right, good luck.
Alright, so this should be a mostly straightforward change to our algorithm. You know, I'm just going to copy paste all this. Not pleased with this code at all, but hopefully we get it working at least. Okay, so we don't need to do this. We're just going to do step equals 0 and just loop forever. Plus step here, and on this stage we first let's put this in a function. Calculate first synchronization point, which is going to take our map. Our map is, yeah, I have a typed F for it. Map T. Yep. Okay, so we're going to take our map, and then we're going to do just check if all of these are -1. Which we could do it a functional way, but we're just gonna do it imperatively. Synchronized equals false. We want to make sure that we're doing this loop where we loop inside the halo. Like so. If map ij is not equal to -1, then we'll put this in a function so we can just return early is synchronized. Take our map. So if it's not -1, then we're not synchronized. If we get to the end and all of them have been -1, then we are synchronized. Okay, so we can just do if is synchronized map return step. Okay. Cout calculate for a synchronization point for our map. Okay. Let's just run this, see if we get the right answer first time, and if not, we'll work out what went wrong. 1562. Did I run the right part? No, I did not. Two, 6, 7. Let's give it a try. Not the right answer, too low. Okay. Well, let's try with the original input, see what answer this gives us. 194. What's the correct answer here? Oh, 195. Is it literally an off by one error? Again. So many off by one errors today. Hi, Marshmallow. Yes, you're a very soft boy. Would you like to say hi to the stream? Where are you? Here's Marshmallow. He says hello. Would you like to wave? Hello. He is just a big teddy bear, aren't you? Aren't you? 2, 6, 8. 2, 6, 8. That's the right answer. We did it. Say bye to the stream, Marshmallow. Bye bye. Let's tell Yosh that we're done. And you
So cute. So cute.
He has a little bed right next to my desk that he likes to sit in sometimes. And now his fluff is all over my desk. Alright, let's tell Yosh we're done. Hey Yosh, we're done.
No surprises. Amazing. Do you want to stream along with this one?
Yep. Mm-hmm.
Yes. Shall I do the live share link again?
Yeah, I do live share link. God, I had so many off by one errors in this puzzle. Like 4 different times I had off by one errors. It was really bad.
Oh, I'm sorry. We are still going through the first one.
And the second one's a pretty simple modification to the first one. So the first one is where most of the work is.
Yeah, it seemed like it. Okay, I've tweet DM'd you the link.
All right, let's join Yosh. Join live share. We'll hide the collaboration link.
Sneaky, sneaky.
Sneaky, sneaky. Connecting.
Yay, Cybrand has joined. And not like last time, Cybrand has joined. Cybrand has left.
All right. So, let's see where you are.
We're on line 46, writing our little implementation. We had to fight the bar checker for a sec. If you see line 14 to 23, we have a nice little like 4 row in grid and then 4 cell in row. And then if you want to essentially modify anything else on the grid rather than like what you currently have, the bar checker says, no, we won't let you. So to like rewrite that loop again and be like XY coordinates and like loop through it that way.
Yeah. All right. So you loop from 0 to 100. You first increase all of the values, then you loop through all of them again, and you if it's a value, then you count the number of flashes.
Let me just rename that to flash count.
And then you set the cell to be flagged, and then you call update. What does update do?
Nothing yet.
Nothing yet.
That was where we were just at. We want to like recurse through the thing, through the grid. And then for every like adjacent like item or adjacent position, we want to like update it.
Sure. So you could do it recursively. That's how I did it in day
Yes.
9. This time I did it with a queue.
With a queue.
You start off with
Oh,
a queue initialized to all of the octopuses which are greater than 9, and then you keep running the algorithm until your queue is empty, popping off values, checking all the adjacent members, adding those to the queue if they need to be processed, and then you just keep running until the queue's empty.
I see. I think I'd rather do it recursively in this case. I feel like that might be potentially the easier one. What do we do this? Oh, we need to give the flash count. U size. U size. Something like that.
Okay, so you're doing, if the number is 9, then flash count plus equals 1. You set the cell to flagged, and you return the new flash count.
Yep.
Yeah, this is just like the flooding that we saw in day 9.
Yes.
Okay, so if you're gonna recurse here, then you
Want to have all the...
yeah, I guess you can do that inside update. Yeah.
Yes. And we know that we already like added the halo, which is our state concon wall.
Yeah.
So I think we can like
Loop through all adjacent members, and if they are not a wall nor flagged, then call update on them.
yes.
Yeah.
Can we do something like this? Y minus 1. Y plus 1.
Mm-hmm. Do you want that to be inclusive?
I definitely do. Did you say there you had off by 1 errors?
Mm-hmm. I totally off by 1 errors. Yeah.
Amazing. This should give us like every single position on the 9 grid.
Mm-hmm. Yep.
Right. Yes. What can we do here? Do we increment the position by 1? Wait, I feel like we could just straight move this in there. Is that right?
I don't think so. Because I think you want your flash count plus 1 and your cell update to be outside this loop. Because you're going to presumably call update on all of these adjacent locations, right?
Yes.
Yeah, but you need to make sure that you update the flash count for yourself first and set yourself to flagged as well. So I think you can just put the flash count and flagging outside the loop.
All right. Well,
because that's going to be called for all of the adjacent members anyway.
Yeah. Variable does not need to be mutable. Wait, what?
Because you're not mutating cell.
We most certainly feel like we
You
are.
are.
So what's going on? Cell? No. Add reference here. Okay, well, cell there. I hope this is right. Yeah, we're clone, not copy, so... Okay, I hope that does the trick.
That feels...
Okay. Weird.
That feels weird. I mean, my Rust is rusty, but that doesn't feel right. That feels like, aren't you? Wait, did you say your clone not copy? So that won't make a silent copy, which you're then.
Yeah, exactly. I think what happens is we never. So the binding is not mutable, but we dereference through the binding to the actual like memory location, which is mutable because our grid is mutable. But it's not intuitive at all.
I guess this is like a similar to C++, where a pointer might be const, but the thing it's pointing to might not be.
Exactly that.
Yeah.
Yeah.
Hey, Jakar. Original Free Zombie said, yeah, exactly what I just said.
Match cell, continue, and then this becomes what do we call this?
You want to match on if the value is greater than 9, and you don't want to you don't want to do the flash count increment and the cell update inside that loop, because you're going to do it when you call update recursively. This will end up incrementing flash count twice for each one.
Why will it do that?
Because you call update.
Because I call update.
And update is already updating the flash count for each element. And then you're updating flash count again for the element afterwards. You just want to kill both these lines.
Correct. Oh, whoa. Okay, I didn't expect you. All right.
One thing right now, you're also checking. So you're checking all the adjacent elements. You're also checking the middle element. You want to not check the middle element.
But we've already like flipped the middle element. That doesn't matter. Like we will never like increment it twice. State flag, continue.
Okay. Yeah. Fair.
Yeah. That's why I was like thinking like we don't like need to increment it like initially, because this will also like catch it.
Oh.
Wait, is that true? No, that's not true. Never mind.
No, wait, that looks, yeah, seems useful.
Hopefully not the worst. Yeah. We have an issue somewhere. Do we have like a brace too much? Yeah, it seems right. Cal borrow is mutable. Is that what we need to do? Hey, variable does not need to be mutable. Okay, well, weird, but let's take a look. Is this it? Run test. Potentially. Overflowed stack. Love that.
Yeah, that's why
Great.
I did this with a queue.
Do I have a recursion counter? No, we don't. But we can attempt to do a flash count right there. Let's do this once more. That is many flash counts.
That's around. That's more than you. Is this for the test input?
Yeah.
The test input shouldn't have that many flashes. The test input should finish at 1,656 flashes. So you have some issue with your algorithm past the stack overflow.
That's good. That's good. Because are we setting the state of the cell to flagged? Yes. Or are we? I wish I had like a better like debug gimbal on my thing. I'm getting the wrong cell. People are saying in chat. Oh, hey, that will do it. X1, Y1.
Yes.
Is that it? potentially. X and Y. All right, well, let's try again. Because that will indeed like just loop forever, right? Assertion failed. Left, right, 100. Okay, so what was the answer for a test input?
Like
1656.
yeah.
Okay, so we have a 0 there. So that's expected to fail. Let's run again. Flash count left 100. 100 is an interesting number.
It is, because that's the number of times you iterate. It's like, are you returning the wrong thing?
Yeah. Yes. So something is going not right. What if instead of this, we do that? And mute there.
Mm-hmm.
And then we remove that. And then we remove that. And then we say and mute. There. Cannot be passed as mutable. Can we just say flash count then? Is that right? Yeah, we can. Does that mean? No, we can't. Okay, well, let's see if that was a bug, that we were like not incrementing flash count correctly. But we are. What? What?
What did you get this time?
100 once
100
more.
again.
Yeah.
Yeah, something's going weird there.
For whatever reason, flash count's always incrementing exactly by 1. Yeah, that's right. Let's take a look at the value of cell. Because we're looping over these cells. Oh, okay, hold on. This needs to be in there. Run once more. Okay, so we have flagged, and then there's a value 10. Value 10, flagged, flagged.
You don't reset your flagged octopuses at the end of each iteration. At the end of each iteration, you need to go through all of your flagged octopuses and change them to value 0.
Yeah, that makes sense. Okay. Yeah. No, absolutely. For row in grid dot row. For row in grid. For cell in row. I think we can do and mute match cell. Come on. Vex state. Iter mute. Still no. Missing match arm. Okay, well, fill match arms. Okay, then we say here.
That's a really nice feature, that fill match arms thing.
Yeah. And here then we say cell equals state value 0.
Yep.
I think. Cool. Run. Testy test. Oh, let me remove the debug. Okay, let me stop that because we're stuck on printing. 1,000. Interesting. So that is still not right. Fascinating. We're not quite having off by 1 errors, but we're having like the answers are too round.
Yeah.
All
It's
right.
like you're somehow so you're iterating 100 times, and each time your flash count is getting updated by 10 or something. I don't know.
Yeah. Yes, that is exactly what we're doing.
Feels like the flash count incrementing is not correct somehow.
No, you're right.
All right, so you're. Let's have a look at this. So you. How do I tell LiveShare to stop following your cursor?
I have a follow participant command, which is Control-Alt-F in VS Code.
I'm gonna try focus participants.
Hey.
Right.
Cybrand focused your attention.
Nice.
Yes.
Okay, so you loop through everything, you increment all of your values, fine. You loop through everything, you get the cell. If it is a value and it's greater than 9, then you call update on it. Calling update increases the flash count, sets the cell to flagged, then loops through all of the adjacent elements. If it's flagged or a wall, you just keep going. If it's a value, then if that one needs... Right, the problem is when you check all of the adjacent elements, you need to increment those adjacent elements first. Remember, when an octopus flashes, it increases the energy of all octopuses around it. You're not doing that part of the algorithm.
Yeah, that's true. Oh, I see. So we need to like do one pass first.
No, I think you just need to do that. Or however, is that valid for syntax? I can't remember.
Yeah. No, that's perfect. Hit save. All right, I can hit save and we can like run it again. Ta-da! That was it. Perfect. Cool. Let's run this with the actual input. Cargo run. Yay. Day 11, output 1, 1729. That seems possible. Yay, that worked.
Yay. Alright, part 2 should be reasonably straightforward then.
Yeah, I'm gonna time box it to 10 minutes.
Yeah.
Because I have something I need to run to later today. So let's see if we can like knock this out.
Yeah.
Synchronizing. So essentially what we want to do is we want to... Here was the... Every time we say flash, I think. Hold on. Update. Flash count. If we reset the flash count like every round, and
I mean, you could do that. All I did was, so before you run through all of your flagged elements and set them to 0, I just had a something in here which checked if all of the octopuses were flagged, and if they were, then it really returned the current iteration you're on. That's it.
Yeah, that makes sense. Walter in chat was like, time for a good old iter.all. I think that's exactly what we should do. All right. I'm going to be terrible. I'm going to copy and paste this.
Exactly
the contents of this. Yep. Is there in C++ ranges, is there like an iter.all equivalent?
All of. Std range is all of.
Nice. All right. Grid dot iter dot all. Is this line? I think this is line. Line dot iter dot all. Cell, and then here we say cell equals state flagged.
Or wall.
Oh, yes. Wait, hold on. We can do this better. Matches. Wait, hold on. How does matches work? Input and then the yes. State flagged, or state wall.
Nice.
Yeah. And then iter all gives us back a pool. Oh, we need to actually call that function. Cannot find s in scope. That's because we underscored that one. Okay, variable exists, and now we have complete. And they want from us. They want the step.
Yeah, so instead of looping from 0 to 100, you just loop forever and you keep a counter.
Oh, I see. For step and 0 dot dot. And then here we do
If complete return step.
Yep. Return step. Flash count. Oh. Okay. And our second test is, hey Nori, 195, right? Is the test input here?
195, yeah.
Can everyone see the cat here?
Oh,
hello.
Hi.
Yeah. She's big and filthy and she wants snacks. I can tell. Yes. I'm getting like love that I only get when I provide food. She's like, please, food. Okay. Hold on. We just ran that. This is how we code. Okay, I'm running a test.
Test failed.
Test failed. Oh no. What's the output?
194, off by 1.
194. Okay, off by 1.
Just return step plus 1.
Yeah, you think so?
Yeah.
Oh, yeah, because we're not counting like... No. We can do it more elegantly.
No, just
We
do step
never
plus
have-
1.
No! 1 dot dot. Because we never have a 0th step. We're always on the first step. Yeah. Is this tail recursion? Go away. All right. Day 11, output 2, 237. Submit. Let's see. Yay, right answer.
Yay.
With
Yep.
5 minutes left on the clock, we made it.
All right. Thanks, everyone,
All
for
right.
tuning in.
Thanks.
We'll stop
see
live
y'all
share and
tomorrow again.
I'll go
All right.
push my crappy code.
Yay. Okay. I cut my stream.
All right. See y'all later.